Okay, so this video is the Unit 9 review packet, and we'll do numbers 8, 9, and 10, so that's page 4. So number 8, the question is about the area of the shaded region. I don't know, I think this showed up on your page, but this part is the shaded region, not the 51-degree sector. So we're looking for the area of this region, and you can do it two different ways. Oh, and it says the radius is 9. So one of the ways you could do it is by finding the area of the whole circle and then subtracting that region. So that would be pi 9 squared minus this area. So the area of the sector right there is going to be the percentage of the circle, 51 over 360, times the area of the circle, pi 9 squared. So then we would subtract out that part, 51 over 360 times pi 9 squared. So this is the area of the shaded region. And then you could figure out what that is. Or you could do it another way. You could think of this whole part here, that whole shaded region, as a sector. It is a slice of the pie. It's just a gigantic slice that happens to be 309 degrees big. So you could also say the area of the shaded, so I'll do 4 here, the area of the shaded is 309 over 360. That's the percentage of the circle the shaded region takes up, and we want a percentage of that area, the total area. Either way you work it out, you're going to end up with 218.419. So that's the area here, 419. Okay. So let's take a look at number 9. Number 9 talks about graphing a circle with center point -4, 2. So -4, +2. So that's the center. And it passes, the circle goes through the point -4, 12. So that's up here. So notice that's those are 10 units apart. So the radius here, notice this means that the radius equals 10. So to graph the circle, I can go 10 units up, which gives me the -412. I can go 10 units down, which would give me -4, -8. I could go 10 units to the right, which would put me at 6 for the x value, and the y would stay at 2. And I can go 10 units to the left and end up at -14, 2. And here's the circle. Oh, and it also, notice it says, prove that the point 2, -6 should be on the circle. So that's going to be about here. So I know that point should go through the circle too. So here's that circle right there. Okay. All right, so to prove that the point 2, -6, to prove that this point, I'll put it in red, to prove that that point is on the circle, what we want to do is show that it's exactly 10 units away from the center. So I'm not going to put a 10 there. I'm going to call that x. That's what we're going to solve for. And if x happens to be 10, then you know it's got to be on the circle. What we can do is draw in this slope triangle. So that would be a drop of, let's say it goes from 2 to -6, so a drop of 8. And the run, -4 to +2, is 6 apart. So then I can do 8 squared plus 6 squared equals x squared. And if you work that out, you get 64 plus 36, well that's 100, equals x squared. So x equals 10. And so you can say this, since the distance from the center point, -4, 2, to the point 2, -6 is 10 units, radius equals 10, the point 2, -6 is, or let's say must be, on the circle. Okay. Let's see. Part C says, sketch the tangent line to the circle at that point, 2, -6. So I'll put that in blue here. So here's the tangent line right there. Okay, so that's part C. And the question says, what's the slope of the tangent line? Well, we know that this radius right here is drawn to the tangent line. And so that means that these guys have to form right angles, right? Here, I'll highlight this in blue also. And we already have a slope triangle drawn for the radius right here. So this guy's slope is, it's downhill, so it's -8/6. Since these are perpendicular, whoops, since that's perpendicular to the tangent line, this slope has to be +6/8, or if you wanted to reduce it, you could say 3/4. Okay, so when I write point slope form, remember that m is slope, and the x1, y1 is any point on your line. Well, we're looking at the tangent line, and I know that the point 2, -6 is on that line. In fact, that's the only one I know for sure is on that line. I already know my slope is 3/4, and I know the point on that line is 2, -6, so then I'm just plugging those in. So the equation of the tangent line is going to be y minus -6, so +6, equals the slope, x minus the x1, which is 2. So there's the equation of that tangent line. All right, and then let's take a look at number 10. So 10 says, figure out the total area of the regions between the circle and the square. So that's this part with this part with this part with this part. So that's what we're trying to add up there, these 4 regions. So really the easiest way to do this is to figure out what's the, so we want the area of the square, and we want to get rid of the area of the circle. So a square's area is going to be, if I just draw a square by itself, all the sides are the same, and since it's also a rectangle, you know rectangle's length times width, so area of a square is x times x, x squared. So we need to figure out, well, what's the side of the square? Well, notice if the radius of the circle is 7, and I draw one radius here and one radius there, then you can see that this length from here to here is 14. So this length, since it's a square, is also 14. So the area of the square is going to be 14 times 14, or 14 squared. And then the area of the circle, remember area of a circle is pi r squared, so pi and then the radius is 7 squared. So if we plug that in, here's the calculator, it's 14 squared, or 14 times 14, minus pi times 7 squared. So that ends up being 42.062. Okay, hope that helps a little bit.